sense. This thing on the top left here is Tectio router. These guys from MIT, they made a handheld router that's a little robotic computer-controlled router, right? So it's a little handheld router like you'd use in woodworking, but the router itself can move a couple inches back and forth within the little case that you hold, right? It's got a little camera on it, it's got a little screen, and what it does is you can actually say, I want to cut a straight line from here to here, and as long as you keep the dot in the circle, it will adjust the router to take all your jaggy motions out and just cut a perfectly straight line, right? Or I want to cut a star shape out, and I don't have the skill to actually do that by hand, but the machine will totally help you do the fine motor control to make that work, right? So I think we're going to see a lot more stuff like that, where it's not about making some machine like we have. Like we have a giant robot that does the exact same thing, and I don't have to keep a dot in a circle or anything. I program it, tell it what to do, walk away, it cuts stuff while I'm off working. But in this instance, anybody can pick that up and use it, right? You don't have to program it, you don't have to know CAD. That kind of semi-automated kind of approach is just huge. A great thing on the top right there, too, is people working alongside robots. So a robot arm like this one that's carving out foam, it will kill you if you stand next to it, right? If it swings over while you're working next to it, it will cause a lot of damage to you. They're big, they're heavy, they're very powerful. So this thing has to be in a cage by OSHA rules, and you can't go anywhere near it when it's working, right? But that robot up there at the top, that's a special robot that this company called Universal Robotics is making. It's all belt-driven internally. If that robot arm hits you, it doesn't hurt you at all. It just hits you, and that's it. Like it has a slip belt system on the inside, so if it hits something, it doesn't do any damage, it just stops, right? So that arm is what's loading and unloading that CNC mill that machinist is working at. So instead of the machinist wasting his time loading and unloading the mill, the robot arm loads and unloads the mill, and that guy can do higher value tasks, right? So semi-automated. Like I'm not trying to make it to where nobody's ever needed, but I'm keeping a human in the loop because humans are awesome and they do great jobs, right? But at the same time, I'm working side by side with them. The other thing is that a friend of ours that does big, massive sculptures, he did the bow and arrow on the waterfront here in San Francisco. His name is Bill Chrysler. He's a really awesome guy. And he has a CNC machine the size of a basketball court. It wouldn't fit in this room. It's a 5-axis machine. He bought it from a boat builder. It's massive, massive thing. For a lot of their projects, when they're doing complicated sculptural work, they'll actually have the CNC router only get it about 80% of the way there, and then their talented crew of sculptors comes in and finishes the 20% by hand because it's faster, right? It's that 80-20 rule. It's like the machine can do 80% of the work in 20% of the time, and then that last little bit of finishing work is done by hand because that's where the artistry and the craft really come into it to make the piece really good. Like if you tried to make it to where it came off the CNC machine 100% done, you're going to spend 100 times the amount of time in programming the CNC machine, and it still might not look as good because it didn't have that final touch that a talented sculptor is able to do. And lastly, this is a protein folding diagram. One of the cool things is when you start to make things with robots is you can make things, the joke that we say is that you can make things that want to be built, right? So if you put all the parts in a box and you shook the box long enough, you'd wind up with the assembled cabinet like what's under the stairs over here, right? It's a theoretical idea, but basically we can make it so that stuff only goes together the right way, right? So again, it's semi-automated. I'm not trying to make a machine that will assemble cabinets for me. Instead, I'm making really smart parts that are really simple for anybody to put together to make a cabinet. So everything's kind of like IKEA-like or something, And nature is a great example of that.